हाय एवरीवन, वेलकम टू जुगाड़ मैथ्स। यहाँ मैं तुम्हें सिर्फ मैथ सॉल्व करना नहीं, इसको समझना और सोचना सिखाऊंगा। ऐसा सोचना जो तुम कोई कॉम्प्लेक्स क्वेश्चन हो उसे दिमाग में ही क्विकली सॉल्व कर पाओ। चाहे तुम अपने स्कूल एग्जाम्स की प्रिपरेशन कर रहे हो और कॉम्पिटिटिव एग्जाम्स के लिए लाइक गई, यहाँ मैं तुम्हें क्लियर कॉन्सेप्ट एंड स्मार्ट अप्रोचेस और एक पावरफुल पर्सपेक्टिव समझाऊंगा सोचने का कि तुम कैसे क्वेश्चन सॉल्व सोच सकते हो अपने दिमाग में, कैसे तुम मल्टीपल स्टेप्स को अपने माइंड में ही सॉल्व कर सकते हो विदाउट इवन राइटिंग इट ऑन द पेपर. So let's begin our journey with trigonometry. So we will be covering trigonometry in three steps. First will be trigonometry basics, which cover NCRT and some basic problems. All the basics related to trigonometry, all the formulas and all. Second one will be trigonometry intermediate, where we will be solving some problems related to JEE mains. And in the third phase, we will be covering trigonometry JEE advanced question. So let's begin. And the first question for everyone is like why trigonometry is introduced in the mathematics. Okay, so this is the first question I have, and I got two examples from the NCRT book, which say the first one is suppose एक स्टूडेंट है, वो किसी कुतुब मीनार के टावर के टिप को देख रहा है, राइट? एंड उसे ये पता है कि वो उस टावर से कितनी डिस्टेंस पर है. हाउ कैन ही मेजर height of the tower without actually measuring it manually, right? If we know the angle he is elevating from that point to the tip and the distance, then how can he calculate the height? This is the one uh, problem statement. Second one is suppose a girl is sitting on the balcony of her house and located on the bank of a river. She is looking at the flower pot placed on the stair of temple situated nearby on the other bank of a river. नाउ इसमें आपको ये पता है कि इसकी हाइट कितनी है जहाँ वो लड़की बैठी है. सेकंड आप फाइंड ये करना है कि ये रिवर विड्थ क्या है. आप कैसे पता कर सकते हो? आपको ये एंगल पता होगा, लेट्स सपोज इट इज थीटा. सो इन्हीं प्रॉब्लम्स को रिजॉल्व करने के लिए ट्रिग्नोमेट्री को इंट्रोड्यूस किया गया मैथ्स में. ट्रिग्नोमेट्री से ट्रिग्नोमेट्री इज अ स्टडी ऑफ रिलेशनशिप बिटवीन sides and angles of a triangle. Let me write it for your notes. Trigonometry is comprised of three words, which is tri, gon, and metron. We all know tri means three, gon means sides, metron means measure. We can get the measure of all the sides of a triangle if we have the other parameters with us. Uh, so in trigonometry, we will be discussing about only right angle triangle, and I know that you know about a right angle triangle where in a triangle one angle is 90 degree and others can be anything, right? So there is one property, as you all know, in any triangle, that sum of all the three angles is 180 degree. uh, Sorry. Here angle B is 90 degree, right? So this is, you can use this equation in the solutions, right? Uh, Now let's move on to next steps, trigonometry, ratios. नाउ अब एक ट्रायंगल के अंदर ना बहुत सारे रेशियोज हो सकते हैं विच इज कम्प्लीटली बेस्ड ऑन दिस लेंथ ऑफ साइड्स ऑफ अ ट्रायंगल। ठीक है। अभी हमारे पास एक ट्रायंगल है, टेक इट एज अ राइट एंगल ट्रायंगल, आई एम नॉट मेकिंग इट एक्यूरेट, ए बी सी, जहाँ पर हम अगर इसे एज अ सी एंगल भी लिख सकते हैं और लेट्स से थीटा। सो ए बी क्या रहेगा, वी कैन कॉल इट एज अ साइड विच इज अपोजिट टू एंगल सी और थीटा, राइट। बी सी जो होगा हम इसको कहेंगे साइड विच इज एडजेसेंट टू ट्राइंगल, टू एंगल सी। एंड जो ए सी होगा उसे हम हाइपोटेनस कहते हैं। And there is a very famous relationship between these sides lengths, that is AC square equals to AB square plus BC square for a right angle triangle. It is nothing but Pythagoras theorem, which is perpendicular square plus base square equals to h square. That is hypotenuse square. Now, what is P here? Perpendicular AB here, base is BC here, and hypotenuse AC here. So we have these relationship, and uh, there are multiple ratios we have. Like, what can we say? This in terms of any angle, AC upon BC, AC upon AB, AB upon AC, AB. Uh, see, let's say BC upon AC. One is remaining. BC upon AB. Right. So there is a relation between this ratio and the angle of a triangle. Like if we talk about the angle theta, it has a relation between with all these ratios. Now in trigonometric ratios, we are having six kind of ratios, that is sine of angle theta, let's say. It says that the side opposite to theta upon hypotenuse. In this triangle, we can call it as AB upon AC. Let's move forward. Second is cosine of angle theta, which simply says the ratio of side adjacent to theta divided by hypotenuse. And in this triangle, we are having this ratio as this. Now third is tangent of angle theta, which simply represent the ratio of side opposite to theta. divided by side opposite to, sorry, adjacent to theta. And in this we have as AB by BC. Now cotangent of any angle theta is side opposite to, not opposite, side which is adjacent to theta divided by side opposite to theta. And we have it is like this, right? Second last is secant of angle theta. It's a, it says the relation, sorry, the ratio between hypotenuse and the side adjacent, which is nothing but AC by BC. Next, the last is cosecant is of angle theta is hypotenuse divided by side opposite to angle theta. We have this as this for our triangle. Keep all these ratios in our mind as they will be very helpful for solving all kind of problem in trigonometry. And there is one note I want to mention here is we have to try the problems by converting them into sine, cosine, and tan. Because in the next lectures, we will be very comfortable with the formulas we will be having in sine, cos, and tan. So there you got all of these relations like this. You can keep in your mind in this way. P, B, P on H, H, P. Pandit Badri Prasad Hare Hare Bol. Where H, P by H represents sine ratio, B by H represents cosine ratio, and third one P by B represent tangent ratio. And all the rest of the ratios are just reciprocal of these ratios. Like cosec is reciprocal of sine, and sec is the reciprocal of cos theta. Cot is reciprocal of tan theta. So you can keep this shortcut in your mind in order to remember all of these trigonometric ratios. Right. Now we all know about all of the trigonometric ratios. So let's try to solve first question. Let's say we are having a triangle where right angle is at B, and C. Let's say this is theta, and we are given a ratio of AB upon BC as 1 upon 3, let's say, and we have to uh, find out find out. First is sine theta, second is cos theta, third is tan theta. We have to basically find out all of the trigonometric ratios. Sec theta, 6 one is cosec theta, right? So as we have AB by BC as this, let me change the color for good visibility. So here we are solving this problem. Now we are having given meant as this. Now most of the teachers will be saying that AB should be considered as 1 and BC should be considered as 3, but it is not always true because AB could be 3 and BC could be 9. So the ratio can be 1 by 3. And AB and BC can be in any values, but the relation of their ratio is 1 by 3 here. So it is mandatory for us to keep them like this. We have to multiply AB and BC ratio with some particular constant number so that we are not keeping it a constant values or like static values that AB should be 1 and BC should be 3. It's not the case. Let's imagine this thing, right? So what we are not having right now is AC. We all know a relationship between in a triangle by using Pythagoras theorem is square. We have AB BC plus 3K square AC square. K square plus 9K square equals to AC square. Now AC square equals to 10K square. AC equals to plus minus root 10K. We all know that length cannot be negative, so ignore AC equals to minus uh, root 10K because of negative length. Our answer for AC would be root 10K. Now we are having all of the three sides. AB as K, BC as 3K, and AC as root 10K. We have to find first thing sine theta. What is sine theta? Here is AB upon AC, right? K upon root 10K. So the ratio is 1 upon root 10. Second thing we have to find is cos theta, and that is BC by AC, K upon root 10K. So our ratio is this. Third thing is tan theta, AB by BC. It is already given in the solution. Fourth one is cot theta, which we already know that this is reciprocal of theta. So let's use this relation. And it is the best practice to find out the values of cot theta, sec theta, and cosec theta. We also know that sec is 1 by cot theta by root n. Sixth This is the value of cosec theta, right? So this was the very basic problem we have solved in the trigonometry. It's like there are a few more questions which I have from NCRT. The next one will be a proof. And example number two, it is given in NCRT that if B and Q angles are acute angles, are acute angles, it's that sine of B equals to sine of U, then prove that angle P equal to angle Q. We have two uh, triangles A, C, P, and a big triangle Q, R, Q, P. We have to uh, prove that is both angles are equal. We can do this by using the properties of trigonometry ratios. So as you all know that it is given that sine B equals to sine Q, right? So by using trigonometry ratio, we can find the value of sine B and it will be AC by AB. Same thing is we have to find the value of sine Q and that will be PR by PQ, right? Now these both values are equal by the relation. So we can say AC by AB is equals to PR by QP, let's say. So let's take it as K, right? So there is relation we have assumption. AC equals to K times AB and PR equals to K times QP, right? We have this relation. We will be using in our future. Now what we can do is uh, like in triangle ABC, we can say that BC will be equals to root under A B square minus A C square by using Pythagoras theorem, right? And in second triangle, we can say that Q square minus P R square. Now, what is BC? Here is AB is still there minus what is AC by the equation K times AB, K times AB ka whole square. Similarly, for QR, we are having it like PQ square minus K times PQ whole square. So BC we can say is AB root under 1 minus K square. Similarly, QR is also PQ times root under 1 minus K square. If we try to find out the relationship between BC and QR, let's take the ratio. It will be this Q root under 1 minus K square. Now these things are cancelled out and this is PQ. So BC upon QR is equals to AB upon PQ. We can rewrite it as AB upon BC equals to PQ upon QR, right? If this is equal, by using these equations, we can say that the triangle ABC is similar to angle triangle PRQ. My bad. I had to write it CP or ABC. So as a result, we got it like this. And if these uh, triangles are similar, we can say that triangle P is equal to triangle Q. As proof. We have find out these equations like second equation, and the first equation is one which we use is first one. By using first and second equation, we have concluded that the both triangles are similar and angles B and Q are same. Right. Now I also want to tell you other relation between cosine and sine. You can take it a note. Uh, like we have Pythagoras theorem which says b square plus b square equals to a square. This further analysis that how can we use find a new relation combining this ratio. What is this? P upon H. This is sine theta plus what is this? Cos theta. Now got a relation between sine square and cos square or sine and cos. The sine square theta plus cos square theta equal to 1. You can write it as cos square theta equals to 1 minus sine square theta. And you can also use it like this by using the a plus b a minus b property. We can write it like this. We can use this relation in some problems. And similarly for sin square theta, 1 minus cos square theta, we can also rewrite it as this. There will be a lot of problems where you will be finding that these relations are very helpful. And let's solve another problem that question. In a right angle triangle, ABC, right angle is at B, then A equal to 1. Then we have to prove that 2 sine theta cos theta equals to 1. Okay. So if tan A, if it is talking about A angle, then let's say the triangle is this. We can take it like A is here and C is there, but it is not mm, making any difference for this particular problem. Okay, so let's solve this. So in triangle ABC, we know that tan A, what is tan A here, right? What is tan A here is BC upon AB, right? And it is 1. So what this says is AC equals to AB equals to BC, right? This is our first relation that we got here. Now another is let's find another relation in AC also, because we have to use sine and cos, so we should know about the hypotenuse. What would be AC? That will be is BC square plus AB square, right? As we know by the first equation that both of these values are similar, so we can write AB in terms of BC here too. So 2 BC square. AC can be written as root 2 BC, right? This is second equation. Now we have to calculate sine theta and cos theta, and there is one another solution we can think of, but let's say we have to go in this way as of now. Sine theta is P upon H. Now what is P here is BC, and what is H here is AC. I hope you all got it. BC, what is BC? BC and AC is root 2 BC, right? So I found that sine theta is 1 by root 2, and similar for AB divided by root 2 BC. By first equation, these both terms are equal. So I got that sine theta as cos theta are 1 by root 2. Okay. Now we have to find the value of 2, finding the value of 2 sine theta cos theta. Sorry, not equals to 1. We are going to find out the value. 2 multiply what is sine theta? 1 upon root. Similarly, for 1 upon root cos, this is 2 cross 1 by root 2, 1 by root 2, this is 1 by 2. And this came out to be. So we can say that this found P4 and it is verified. So here we solved the problem. Now this one a more interesting problem we have in NJAT in example 5. Let me write the question here is in triangle OPQ, right angle at P, OP equals to 7 centimeter and OQ minus PQ equals to 1 centimeter. I will be giving you a diagram. Now we have to determine the value of sine Q and cos Q. Now we have this triangle. This is 7 centimeter, this is P, this is Q, and this is, sorry, this is O, and this is Q, right? So let's solve this and try to understand what is the exact solution we have for this problem. Now we have OP equals to 7 centimeter. We have another relation that is OQ minus PQ. OQ minus PQ. We have OP. Okay, that is PQ. Right. PQ equals to 1. Uh, we can rewrite it as OQ equals to 1 plus PQ. And let's try to apply the Pythagoras theorem here is, and the PQ square plus OP square equals to OQ square. Now we have OQ in terms of 1 plus PQ, let's say, and OP is already given to us, that is 7 centimeter, right? The PQ square is also there. OQ is 1 plus PQ square. There is very simple mathematics we can think about. Now 1 plus PQ whole square minus PQ square equals to 7 square. Here we can apply the property of A square minus B square, and that is A plus B multiply A minus B. 1 plus PQ plus PQ to 1 plus PQ minus PQ, 49, right? 1 plus 2 PQ into 1 equals to 49. 1 plus 2 PQ equals 49. PQ equals to 49 minus 1. PQ equals to 48 divided by 2, and that is 24 centimeter. Now we are having values of PQ. We have OP. What is remaining? QO. We can find this by using Pythagoras theorem. PQ square plus OP square, and it is going to be 24 square plus 7 square. That I think it's 484 and 49. No, I was wrong. Not 484. It was of 22 scale. Let's 576. This one is 625, and the answer is 27 centimeter. Now we have all the sides of our triangle, so it is very easy for us now to find out sine q and cos q. Now many of the students will make a mistake here, saying that sine q will be OP upon OQ, and that is totally wrong, because sine q will be the ratio of side opposite to side opposite to q. Right. And what is side opposite to q? That is OP upon hypotenuse. That is OQ. What is OP? 7. OQ is 25. This one will be the ratio. Similarly, for cos q, we have a side adjacent to angle q, that is PQ divided by OQ, and this is going to be 24 by 25. So this is for today's lecture, students. We had a good understanding of what are the trigonometric ratios and how can we use them for solving such trigonometry problems. Thanks for watching, and for more such content, please like, share, and subscribe to our channel. Thank you so much.